All right, here we go. So this lesson is going to start a review, an overview, where questions will come from all parts of the units 1 through 9, all of it. And we're going to go through it together. And anytime you need to press pause, you can. We're going to do 2 pages on this video. So I want you to notice the first question here is understanding how to interpret a graph. The graph below models data collected at an Alta snowstorm. And it's important to know that what you're looking at is a rate, and the rate is in inches per hour. So we're going to keep that in mind. And the time is time in hours after midnight. So midnight, 1 a.m., 2 a.m., and so on. All right, write an integral expression for the total snowfall between midnight and 9 a.m. So if this is a rate, if I integrate the rate, we now can accumulate whatever the rate, the unit is. In this case, it's inches. So if I want to know how many inches of snow, I integrate. And if I'm going from midnight to 9 a.m., that would be 0 to 9. So I'm going to go integrate from 0 to 9. And then we have a function, and it's called p at t up here. So I'm just going to write that down. P at t dt. And that's it. That integral expression represents the snowfall accumulated from midnight to 9 a.m. Write a complete sentence that tells what point A represents. Oh, there's point A. Include numbers and units. So just point A is a rate. So we need to involve both axes. So point A is at what? At 1 a.m. So I'm going to write that down. At 1 a.m., what's happening? The snow, that's the story, is falling at a rate of, 3 inches per hour. And notice that when it's just a point on a rate graph, it's a rate. But if I'm integrating it, then it no longer would be a rate. Number 3. Which of the 7 points labeled on the graph corresponds to the time that snow was falling the fastest? So, where was snow falling the fastest? So, at what point is the rate the greatest? And because it's a rate graph, I'm simply going to find the highest point on the graph. So, which of the 7 points are? It's point E and Y. And it's because P at T has an absolute maximum at point E. All right, number 4. Which of the points labeled there corresponds to the time when the rate of snowfall was increasing the fastest? So we have rate and the word increasing. That's the rate of a rate. So I recognize that that's going to be the derivative or the rate of a rate of what I'm looking at. Acceleration, if you like. When I'm looking off the graph, I'm looking for that. I'm looking at where is it increasing the fastest. I'm finding where it is steepest. And so at what point is it steepest on the graph? And it's steepest increasing, not steepest decreasing. So steepest increasing would be at point D. Now why point D? Because, and it's the derivative So if you want to think of it as a derivative, it's because the derivative has a maximum value there, or P at T has the greatest slope. Both would have a math understanding of why you picked it. All right, I want to integrate from 0 to 5. So if I'm integrating a rate, and I know some of you have a challenge with this, please don't write down the velocity or the rate and so on. Now it's just what the unit is. So this is telling me how much snow. So from 0 to 5 means from midnight. Oh, I'm already answering number 6. So I'll save that. But anyways, how do you actually find it? From 0 to 5. And the answer is you would find the area under the curve from 0 to 5. So I think I see a trapezoid, and I'm just going to go with it. So the area of a trapezoid is 1/2. I'll show my work in a second. What's the height of this? Make sure you know the units. It's 6 inches, so the height is 6. And then what are the bases? So the width, one width is 1, and the other one is 5. And we're going to put that together. So 1/2 times 6, and then 1 plus 5. So that's 6 times 6, and then half of that. And so I get the answer 18 using a trapezoid. Then number 6 is, what does your answer mean? Well, the answer means from 0 to 5 would be from midnight to 5 a.m. How many inches of snow fell? 18. So 18 inches of snow fell. I am not going to write down a rate, 18 inches per hour or any of that. So when I integrate a rate, it's just how much accumulated. So 18 inches of snow accumulated. All right, so that's enough for that graph. Number 7. Can you simplify some logarithms for me? This is not even calculus. So let me zoom in. What happens to E and ln? They cross out and you just have AB. Here, can you just evaluate that logarithm? If the base is 3, what must the exponent be to get 1/3? So 3 to the -1 is 1/3. And again, ln E, they cross out and leave you just with 1. All right, next page. Oh, do you know your unit circle? And then we'll get back to a little bit of calculus. So, number 10. What's the value of tangent at -2 pi over 3? So that's a 60-degree reference angle, which means it's 1/2 and √3 over 2. So when I go y over x, because that's the definition, √3 over 1 gives me √3. The last thing I need to know is what quadrant -2 pi over 3 is. And because I'm going clockwise, it's going to end up here in quadrant number 3. So in quadrant number 3, tangent's positive, and the answer is positive √3. 11. What's the value of cosine at 3 pi over 2? So 3 pi over 2 is at the bottom of the unit circle. It's just the x value at the bottom of the unit circle. Well, the x value at the bottom of the unit circle is 0. That point down there is 0, 1. 12. Arc sine -1. I'm looking for the angle where the y value is -1. Hey, I was just there. So the y value is -1. Its partner is 0. It's at the bottom. But I can't write it as 3 pi over 2. I have to write it as a negative angle that gets down there. So the answer is -pi over 2. And the last one, arctangent, at what angle is it √3 over 3? So I know it's not 45 degrees, because then the answer would be 1. So what order would I put it in when I go y over x would give me this answer? So the answer is, it must be √3 over 2 and then 1/2, because 1 over √3 will give me this answer when you rationalize it. I know it's tough. So the answer would be 30 degrees, or you could write it as pi over 6. All right, find the following limits. So if I want to find these limits, it's a substitution question. So the first question is, as x approaches 0. So if I want to know as x approaches 0, I actually don't care about the middle part. I care about the left and the right. Do they equal the same answer? So plug in 0 and the answer is 3. Plug in 0 and the answer is 3. Right side equals left side, so the answer is 3. This part here, I don't even want to look at. That has nothing to do with the limit. Left side has to equal right side. So from approaching from the left and right, they agree that's the answer. When it gets there, if it's a different answer, that's fine. Here, what happens in this limit question? Well, first step is, can you just plug in? And you can. And then what answer do you get? So the answer is 5 over 3. So at its most foundation, most basic, a limit is a substitution question. If you substitute in and you get an answer that's indeterminate or undefined and so on, that's when you have to do a little bit more thinking and work. All right, 16. Find the following limits showing organized work in correct symbolism. So the first step is, and we're never going to write down 0 over 0. So I'm going to separate the top from the bottom. So from the top, limit as x approaches 0 for sine x. That's a substitution question, and the answer is 0. It's the y value there at 0 degrees or 0 radians. And then the bottom, the limit as x approaches 0 of x e to the x. If I plug in 0 again, the answer is 0. This is definitely indeterminate. So I've shown that. Then I'm going to do L'Hopital's rule. So the derivative of the numerator is cosine x. The derivative of the bottom is a product rule. First times the derivative of the second plus the second times the derivative of the first. Now I can substitute in. So when I plug in 0 now, the numerator is 1 because the value of cosine at 0 is 1. When I plug in 0 in the bottom, that's 0, but e to the 0 is 1. And then put it all together, and the answer is 1. Number 17, a limit question. So again, this is a great one because when it's approaching infinity, is the numerator increasing faster or the denominator? And because the denominator is increasing faster, the answer is 0. You could also use L'Hopital's rule. And then for L'Hopital's rule, the derivative over the derivative over the derivative, oops. But you get the idea that the answer is going to be 0. Okay, number 18. Now some derivatives. Do you know your rules? So let's practice. So it's good to have your sheet out in front of you to understand what are we going to do. So the first thing I see is a big square root sign. So I'm going to write that calculus friendly to the 1/2. Now I'm going to take the derivative, and it's going to go outside to inside. So on the outside, I'm going to do the power rule. So 1/2 times 1 in front, and then rewrite everything else inside. And then you have to subtract 1 from the exponent. That's step 1. Then inside, I have a logarithm. And what's the derivative rule for ln? Well, what you see is in the denominator. The derivative of that is the numerator, and it's over. I'm going to do this because I got a bunch of derivatives to do with you today. I just don't want to go into the other problem beside it. So I'm just creating a little grid for myself to make sure I stay within the lines. Number 19, can you take the derivative of that? I'm going to try to zoom in as best I can here. So the derivative of this, first of all, is the exponential rule. Well, that's an easy one. Copy it. E negative 3x squared minus 1 times, what's the derivative of the exponent? I'm going to put parentheses because it's a negative answer. So it's negative 6x, and that's it. It's over. Number 20, this is the, well, what is it? You decide. Can you try it, number 20? At this point, I think it'd be great if you press pause, you did the work, press play and see if we're right together. All right, this is the product rule. So the first, now if you didn't know the product rule and you did it wrong, press pause again. Now try it again. All right, the product rule. First times the derivative of the second. Now the derivative of the second is square root 1 minus x squared, and the derivative of x is 1. So there it is. Plus, I'm going to continue down here, the second times the derivative of the first. All right, 21. You, then me. So do the derivative for 21, then press play. So press pause, do it, then press play. All right, here we go. The derivative of cosine is negative sine 2x, but it has a little hook of 2 because the derivative of 2x is 2. And then sine ex. So the derivative of sine is cosine, and it's cosine e to the x times the derivative inside, which is e to the x. And that's it. Number 22. You try, then I try. So press pause again, then do the work. All right, we're back. So let's see if you did it right. The derivative. So the rule for e is copy it, and then the hook comes from the exponent. So what's the derivative of tangent? So the derivative of tangent is secant squared. See, the more we practice, the more you're going to realize that you remember more than you think if you choose to practice every day. You're going to be great. And I have a feeling that this, if we're doing this at home exam for 45 minutes, it might be a little more basic than what it would have been for 4 hours. But we'll see. We're going to plan anyways. And anyways, I think you guys are going to do amazing. That's my own opinion. So here we go. What's the derivative here? So first, can you try it? Press pause, and then we'll do it together. All right, so first, the derivative of sine. That's on the outside. That's cosine. And then you rewrite what's inside times. Then What's inside? What's the derivative? And the derivative of ln x is 1 over x. Done. Okay, try number 24. We're going to end this video at 26, so you just have 3 more. So you can do all 3 of them and then watch the video, or do one at a time with me. Okay, you ready to press pause? Try. Now, I recognize that we have ln x over x. So I'm going to rewrite this. Over x means 1 over x. And if I write it this way, you might see it. In fact, if I write it this way, you might even see it a little bit better. So these are equivalent. But if I write it this way, I want you to recognize that the base, what's the hook in terms of what's happening? Oh, wait a second. I'm trying to, geez Louise, don't do that. I was trying to actually try to set up to integrate for no good reason. So this is the quotient rule. Yay? Quotient rule, did you do it? That would be the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. You did that, right? Done. My goodness, my brain sometimes. 25, 2 more. Derivative. Now notice x and y are jumbled up, so this is called implicit. You try it, then I try. All right, here we go. Implicit. The derivative of ln is what you see is in the denominator, and then what in the bottom is the derivatives on top. So the derivative of x is 1, and then the derivative of y is y prime. So it'd be 1 plus y prime. So the derivative of y would be 1, but it needs a y prime. So there's the difference, and the derivative of x is 1. We are going to multiply both sides by x plus y. So x plus y times 1 is x plus y. And then to get, oh, that's a y prime. And then to get y prime by itself, you just subtract. So it's x plus y subtract 1. You could have also wrote this as an exponential. So you could have written and said, hey, I want to write that exponentially. So what's inside is x plus y, and then it's e to the x. And then to get y by itself, you would subtract and then take the derivative, and they actually are equivalent in terms of derivatives. So if you did it this way, this is one method. If you chose to do it this way, you can subtract x and then take the derivative, and that would be e to the x minus 1. Oh, even though they don't look the same, they have the same derivative in this case. Both would be perfect. All right, number 26, last one. Here we go. So what's the derivative here? So on the outside, the rule for cosecant is it repeats. So it's cosecant x squared, and it's negative, sorry. So negative cosecant x squared with cotangent. And then the hook, and the derivative of x squared is 2x. So don't forget that cute little negative, and it repeats itself, and then has a partner, and then the derivative inside is 2x. There. So there's our start of our review. So anyways, good job, Mr. G Math, of course, over and out. And I'll do another video again soon.